Okay, this is lesson 2, solutions, and this is going to be a short lesson. We're just going to concentrate on solubility curves, which we were talking about in our last class. So just kind of going to bring it all together and review what we've already done. So we're going to distinguish between saturated, unsaturated, and supersaturated solutions. We're going to learn how to read table G and determine whether a solution is saturated, unsaturated, or supersaturated. Unsaturated, a solution in which more solute could be dissolved in a given amount of solvent. Remember last time we got together we said that the solute is the thing that's being dissolved and the solvent is the thing that is doing the dissolving. In a saturated solution, a solution containing the maximum amount, I'm going to abbreviate amount, AMT, amount of solute that will dissolve in a given volume of solvent. So if it's the maximum amount, we say that a saturated solution is a solution equilibrium. So it's very stable. So here I have 30 grams of NaCl plus 100 mils of water. I put them together and you can see that all of the solute has completely dissolved in the solvent. It's completely dissolved. This is an unsaturated solution. That means I could add more to it. Here I have 40 grams of NaCl and 100 grams of water, and what happened is there's a little bit that wouldn't dissolve. So it says this is a saturated solution containing 100 mils of H2O and 36 grams of NaCl. So this additional 4 grams remains undissolved. And what we could do is we could determine how much made this saturated solution, because we could take a funnel and some filter paper and we could pour that in it, and this undissolved amount would get trapped on the filter paper. And if we knew the weight of the filter paper first and then we let the filter paper dry out and we reweight it, we could subtract the weight of the filter paper, find out how much NaCl was trapped on the filter paper and subtract it from our original solute, and we'd know exactly how much made that saturated solution. And then we have supersaturated, a solution that contains more solute than would normally dissolve in a given amount of solvent. This usually requires an increase in temperature or pressure. And it's initially very unstable. And I'm not going to demonstrate this. I showed you the demonstration on Friday with the sodium acetate. We saw that clear solution, but they had actually heated that clear solution up to dissolve more than it could possibly hold. It looked like regular water, and then all they did was add 1 seed crystal, and then it all came out of solution, and it formed that solid precipitate. So let's look at some various situations. If I have an unsaturated solution and you add crystals, meaning more of the solute, what's going to happen? Well, hopefully you say that the crystals dissolve, because if it's unsaturated, then you can add more. Crystals dissolve or disappear. So it looks like one clear solution. The rate of dissolving is greater than the rate of precipitation. And what we mean by that, precipitation is when something comes out of solution. It was like that white stuff that we saw on Friday, or anytime you have some type of sediment at the bottom of a beaker that comes out of solution, that's usually precipitation. If you have a supersaturated solution and you add crystals, what will you observe? So, well, we saw that. If you have a supersaturated solution, then you add a seed crystal, all the crystals precipitate out. And I'm going to use the word, I'm going to put this abbreviation, PPT, means precipitation. All the crystals precipitate out. The rate of dissolving is less than the rate of precipitation. If you have a saturated solution and you add crystals, what will you observe? What will happen is crystals will start to sink to the bottom, just a few, the ones that won't dissolve. Like you saw with the 4 grams on the previous slide. Here the rate of dissolving is equal to the rate of precipitation. So here's your solubility curve, and it shows the number of grams of a substance that can be dissolved in 100 grams of water at temperatures between 1 degree Celsius and 100 degrees Celsius. Each curve represents the maximum amount of substance that can be dissolved at a given temperature. All lines that show an increase, so here are your positive slopes, represent solids. And all the lines that show a decrease, remember, for gases. Remember, if my data point in question, let's use I'm going to highlight one of these. I'm going to highlight the NH4Cl. Okay. So, if my data point is on the line, so we're going to mark this A, so you have a guide here. So there's A. On the curve, then we know the solution is saturated, set on the line. If it is below the line, this would be B, so below the curve, then it is unsaturated. And if it is above the curve, it is supersaturated. Some review questions, and that's it. How many grams of NaCl will dissolve in 100 grams of water at 90 degrees? So I'm going to go to 90 degrees, and I'm going to see where that intersects the line right there. So this is number 1, and that's 40 grams. How many grams of KCl will dissolve in 50 grams of water at 30 degrees? So let's go to 30 degrees, and let's see where that intersects KCl, which is right here. So it's number 2. Now this is about 35 grams, or yeah, I'd say that's about 35 grams, but that's in 100 grams of water. So you can do 2 things. You can do 35 in 100 equals X in 50, or you can just say to yourself 50 is half of 100, and you can cut this in half. So half of 36 would be 18, So this is going to be 17.5 grams. How many grams of KCl will dissolve in 200 grams of water at 30 degrees? So we know it's 35 and 100. We just had this question. So how many is it in 200? So you know you have to double it. So it's going to be 70 grams. Name two substances on table G that are solids. So we're looking for a positive slope. So anything that has a positive slope. So we could say Ki, we can say NaNO3, anything that's going upward. There's lots of them. Name two substances that are gases. We want a negative slope. So anything that's going down, like HCl or SO2. And there's only one more, so we might as well put it NH3. Is a solution that is made up of 100 grams of water and 70 grams of KNO3 at 50 degrees saturated, supersaturated, or unsaturated? So let's go to 50 degrees and 70 grams, and let's put a dot. There it is, 50 degrees, 70 grams. This is number 6. Now, where is that in relation to KNO3? Here's my KNO3. It's under the line, therefore it's unsaturated. And you can just write under the curve. At 40 degrees, if 100 grams of KNO3 are added to 100 grams of water, how many grams will fall to the bottom of the solution and won't dissolve? So we have to go to 40 degrees, 100 grams, and put a dot. Okay, 7. And they're asking about KNO3. Well, here's KNO3. KNO3 at 40 degrees can only hold about 62 or 63, and you've got 100. So if it can only hold 62, 63, then this difference from here to here is going to fall out. So 100 minus, I'd say that's probably closer to 63. 63 is going to be, let's see, 63 to 70 is 7. So 37 grams will fall out. And which is more concentrated on table G, point A or point B? So if I were to say that let's talk about NaNO3 for this question. Here's NaNO3. And let's say this is point A and this is point B. Which one of those is more concentrated, A or B, and why? Well, we would have to say B is more concentrated because, why? It holds more grams of solute at what temperature are we at 20 degrees per 100 grams of water. So if you have more solute in a given amount of solvent, it's going to be more concentrated. If you have less, then it would be dilute. Okay, that's it.